spots because they like to pick weird names. And it turns out that these have ferrous iron, so iron 2. So if you have a ferric iron mud, how do you get these weird little green spots of reduced iron 2 plus minerals, phosphates and sulfides? And so they started thinking, oh, maybe this could be life, because on Earth, when you see this kind of thing, it's microbes usually. And it's definitely cool and interesting, but I would say, wait. I wouldn't jump to life quite so quickly. About 20 years ago, I did some experiments in the lab with iron oxides. And if you take ferrihydrite, which is a very common iron oxide, and you mix organics with it, and then you heat it up, then it reduces the iron because of the organics. You can also use zinc or hydrogen or other things, but the organics can reduce them. And it's very easy to test because if they're magnetic, that means magnetite form, and magnetite has reduced iron. So potentially, and this is just a graph showing if you have no organics, you have no peak here. If you have no organics, this gold one, there's no peak here. So these were 2 types of reactions that we did in the lab. So back to this ferric mudstone with these little green and white spots of phosphates and sulfides that are reduced. It could be prebiotic chemistry, which would be interesting. They also noticed that there are organic materials in the neighborhood of these weird green spots. So this could be evidence of chemical reactions with, so organic chemistry. It could be simple hydrocarbons reacting with the iron and the minerals to produce these other new reduced minerals. And potentially this is important. As life evolved, you have to have interesting chemistry between organics and the rocks, the minerals. And phosphorus is also important for the origin of life. So this is the main story I wanted to talk here. I'm happy to answer questions, and I also want to show a little movie. So I think that'll just start next, right? So let's, so this is kind of slow getting going here. My group from my postdoc in Berlin is DLR, Deutsche Luft- und Raumfahrt, and they made this great film from Mark Watney. How many of you went to see the movie The Martian or read the book? So this guy, Mark, in order to survive, he has to get from where he landed, which was kind of near Marth Vallis, my favorite place with all these clays, and near the Pathfinder landing site. And he has to traverse way across Mars. So here he's going across the surface, and he actually crosses through Marth Vallis, which is a place that has tons of clays, and we're going to see that here. It's kind of going sideways. I hope nobody's getting to... Here's Marth Vallis. So all this bright stuff here, this is clays. Clays have tons of water. Had he talked to me, I would have told him, stop right there, grab some of this stuff, and between the night and the day, you're going to have water that you can collect from your clay, and that'll give you something to drink along your journey. But he didn't talk to me, so he had to suffer along his journey. And this is stretched a little bit. I think it's 2 or 3 times. So there are craters here, but they're not quite as exaggerated as this. But this is real Martian topography. So my colleagues in Berlin took real Martian images and made this movie out of it, showing the traverse that he took to get to, I think they called it Ares 4, their landing site, or there in the movie. And is that the end? I think that's the end. All right, well, thank you for listening, and I'm happy to answer questions.
Just amazing, Dr. Bishop. Do we have time for several Q&A moments? Great.
And one other thing, I brought some swag from the SETI Institute. There's some pens and some stickers and bookmarks. One of our secretaries handed me these yesterday, so help yourself if you're interested in any of that.
Hi there. So, of course, the news about these poppy seeds and leopard spots came out last fall, I guess it was.
September 10th.
And I saw a lot of conjecture on YouTube about what could this be other than life-produced deposits in these minerals. Is there anything on Earth like that? Is there an analog here? Do they really think that that has to be a life-produced spot?
Well, the problem on Earth is we have so much life that it gets in the way. And so you can't really see these places. Yeah, it's contaminated with life everywhere. And life, microbes make the reactions go faster. They're a facilitator. So a lot of these chemical reactions that could take place really slowly over 100 years, 1 million years, 100 million years, could take place on Mars. But on Earth, they just go quickly because you know they might go in a few hours or a couple days because of the microbes in the pond. So it's hard to know because we can't really tell how long this went. But I would say it's really it would be a big jump to say there were microbes. So I actually was a reviewer on their paper, and then Nature asked me to write a review, so that's why I know it's September 10th, because I was barraged by journalists. So I wrote a company paper to the big story, and I thought it was a great paper talking about the interesting redox reactions and chemistry that was happening, but some of the other reviewers are like, wait, you can't mention life in the same picture, this is crazy. And I noticed they toned that way down in the paper, but then as soon as it got to the NASA press conference, 90% of it was talking about life, and maybe this means life. Like, wait, that's not what the paper says. So I think that's, it's part of being a scientist and NASA trying to sell their work to the taxpayers and hype it up every time. So it's an interesting result, and it's the first time we've seen this kind of juxtaposition of ferric and ferrous iron in such a small little area, just a few centimeters, with these little spots that are probably like 2, 3, 4 millimeters. So they're tiny little spots.
So I have a follow-up question to Joel's question. So clearly the goal is to detect convincing signs of life.
Yes.
Either on Mars or any other exoplanet. So do you think, and I don't think that's happened yet, so there's a lot of conjecture. Do you think that by the time you retire, there will be convincing evidence of early life outside of the Earth?
I would say 50-50 chance. So a lot of it depends.
Go for it. Yes or no?
Yeah, I think there's a pretty good chance that life evolved somewhere else, but how are we going to detect it? And the instruments we send on these rovers, they're not good enough. So we have to get these samples back. So where Perseverance was, they've cached, they have these cool, it's like a water bottle with a, it's about the size of a thumb, but it has an insulated dual panel container, and so they're putting these samples in there, and they've got, I think, about 30 saved, and they're cached, and they'll be collected and hopefully returned. So on Earth we can do sulfur isotopes, we can do all kinds of SEM that we can't do there. So high resolution imaging and the chemistry, the isotopes. And so especially the isotopes can tell us the kind of reactions that were taking place. So if we could get that done here on Earth, we would know. But Trump canceled the sample return missions. So who knows? Maybe our next president will think it's valuable. Maybe they'll have a different agenda. I don't know. So it was supposed to come back in a few years, but now it's probably more like a decade, and it's a little uncertain. So yeah, if we can get those samples back, I think we have a good chance of really understanding what's going on there.
So I want to thank you for this really interesting talk, and this is a little bit off topic, but it segues off of Don's question about life beyond Earth. You've been looking at Mars for a long time. Do you have a perspective about Elon Musk's ambitions to colonize Mars?
Well, as soon as we send Elon Musk up there, he's going to breathe and exude all of his organics from his body, and so then it's all lost. So we need to collect samples and bring them back before we send humans. Otherwise, we won't know, are we detecting Elon's skin over there, or hair follicles, or are we detecting, microbes that are 3 billion years old? So one of the other interesting things about Mars, comparing life evolution on Earth and on Mars, the earliest fossils we have of life here are 3.5 billion years old, so a long time ago. Some people argue maybe the rock is 3.7 and not 3.5, but still it's about that time period. And at that time there were also a lot of things flying around. Asteroids were still, it was before all the planets were definitely calm, like today. And so on Mars, these ancient rocks, and when we had water on the surface, it was about 4 billion years old. And there's some places that might have been 3.7, like Gale Crater, one of the, where the Curiosity rover is, not the latest rover, the second latest rover. And there was liquid water there in Gale Crater. But still, this is older than the 3.5. And it doesn't mean we didn't have life here before 3.5, we just don't have evidence, because our oldest fossils are 3.5. But the point is, life is probably evolving from this soup of organic molecules, because we see nitrogen and amino acids. We see NH4 on Ceres and the organics. Ceres is a asteroid not too far away, and it has ice and organics and carbonates and ammonia, cool stuff, all those things you kind of need to make life. And probably we had all that stuff on Earth, on Mars as well as Earth, but maybe it was too early. So it could be that Mars had this great environment about 4 billion years ago, but it was just too early because we still were bombarded by everything. And so life could have been disrupted because of all the asteroid impacts and all those impact craters you see on the planet. So we don't know. But maybe, if life's pretty hardy. So when you look on our planet, you go to the Atacama or the Antarctic, there's been nowhere anyone has been where there's no life. There's life everywhere. Some kind of microbes somewhere. And it's much rarer. There's a smaller density in the Atacama or places like that. But there's still life. And so if life did evolve on Mars, I think it'd probably still be there. So they're underneath the surface. It'd be really hard to get rid of it totally. So it might still be there under the surface, or at least fossils. So I think if it did evolve, we would see it. We'd find it eventually. But yeah, if we get an army of Elon Musks around the planet, then we can't use the chemistry so much anymore because of all the bacteria he brought. So it'll be a little harder to try to find those fossils from 3.5 to 4 billion years ago.
So thank you, Dr. Bishop. That was amazing.
Oh, I'm happy to be here. Yes.
5 to 10 years ago, I had my study plugged in for hoping something beat that. Haven't been doing that very often.
I don't think that's going on anymore, but yeah.
Yeah, the ancient history.
Yeah, but thank you for contributing.
Great. So it's our tradition to offer our speaker a bottle of wine.
Oh, very generous. Thank you.
I conferred with your brother, and he thought this might...
Okay, yeah, that sounds good, and it's from Livermore.
RJM.
Does anybody recognize the picture? Is that someone in the room?
It's a red blend of our owner, our previous.
Okay, thank you.
Commemorative label to him.
Oh, that's nice.
And we'd also like to give you these rotary coffee mugs.
Oh, awesome.
It's a new thing we're doing.
Oh, should I open it up? Or sure.
What does SETI mean?
Search for Extraterrestrial Intelligence. So it started as part of NASA Ames in the 70s and 80s. Oh, look at that.
We have to do the band.
Oh, Rotary. Thank you, guest speaker. Awesome. Yeah, thank you. Very nice.
Love the presentation.
Oh, yeah. We'll have to work on this puzzle. Okay.
have to worry about the water.
Thank you.
So next week we have Angela Plummer, Teen Esteem, equipping students to face the unfortunately increasingly difficult challenges growing up in the digital age at Robert Livermore Community Center. That's where we'll be based next week. So there's no ticket, there's just the bell.